A scale drawing is a reduced or enlarged two-dimensional drawing. Scale drawings are proportional and are created using a scale factor. That scale factor tells us the rate at which the figure is reduced or enlarged. You can see an example of a scale drawing on your screen where your actual picture is 3 units by 4 units, and it has been enlarged by a scale factor of 2. The new drawing is 8 units by 6 units. We can use scale factor to find missing side lengths. In this example, you see that we have a scale drawing of a house compared to the actual size of the house. The scale factor used for the drawing is 2 inches for every 5 feet. Whenever we're given a scale factor, we can use the scale factor to make a ratio. This scale factor is 2 inches to 5 feet, so I will write it as 2 inches over 5 feet. To find the missing side length of the actual house, I can take what I know about the scale drawing, which is that the drawing is 8.5 inches. I can set this to a proportion by setting it equal to the ratio of my scale factor. Since the length of the house is 8.5, I'm going to put 8.5 inches with inches from my scale factor. What I don't know is the actual size of my house in feet. Now I can use what I know about proportions to cross multiply and solve. So 2 times x is going to give me 2x. And then I'm going to multiply 8.5 times 5, which gives me 42.5. Now to solve for x, I'm going to divide by 2 on both sides of my equation. These 2's will cancel, which leaves me with x. Now I'm going to divide 42.5 by 2, which gives me a value of 21.25. This means that the height of the house is 21.25 feet tall. From this picture, I can see that an architect made a scale drawing of the front of a house using the scale 1 inch equals 20 feet. I want to know the actual length of the front of the house. Again, if I know the scale factor, that's going to be the first thing that I use in my ratio. So, since my scale factor is 1 inch equals 20 feet, I'm going to write a ratio that says 1 inch to 20 feet. Then, to find the length of the house, I'm going to plug in what I know about the length of the scale drawing. I know that the length of the scale drawing is 3.5 inches. So, since inches were in my numerator here, I'm putting inches in my numerator here. What I don't know is feet, the actual length in feet of the house. To solve this, I'm just going to cross multiply. 1x is 1x, or just x. Then I'm going to multiply 3.5 times 20. Well, 3.5 times 20 is 70. Now, because I multiplied 1 times x and got 1x, I don't even have anything to solve in my equation, and now I know that x equals 70. That means that the actual length of the house is 70 feet. On your screen, you see a scale drawing of a rectangular swimming pool. The scale used for the drawing is 1/4 of an inch to 4 feet. We want to find the perimeter and the area of the swimming pool. To be able to find the perimeter and the area of the swimming pool, I need to know the actual length and the actual width of the swimming pool. So I'm going to use my scale factor to find those values first. I know that my scale factor is 1/4 of an inch to 4 feet. So I'm going to write that as a ratio. Now the first thing I'm going to find is my length. I know that the length of my scale drawing is 3.5 inches. So I'm going to make a proportion where I can find the actual length of my swimming pool. Since inches were in my numerator here, inches will be in my numerator here. And what I don't know is x. So I'm going to cross multiply, and I know that 1/4 times x is 1/4 x. And then I'm going to cross multiply here. And I know that 3.5 times 4 is 14. To get x by itself, I'm going to need to divide by 1/4. These will cancel to leave me with x. And then I'm going to divide 14 by 1/4. When I do that, I get x equals 56. This means that the actual length of the pool is 56 feet. So in real life, The length of the pool is 56 feet. Now we're going to do the same thing to find the width. I'm using the same scale factor, which is 1/4 of an inch to 4 feet. This time I know that the width is 1.5 inches, and I still don't know the actual length in feet, or width in feet. I'm going to cross multiply, so 1/4 times x is 1/4 x. 1.5 times 4 is 6. To get x by itself, I'm going to divide by 1/4 on both sides, and these will cancel to leave me with x equals. And when I divide 6 by 1/4, I get 24. This means that the actual width of the pool is 24 feet. Now I can use those values to find the perimeter and the area. To find perimeter, I know that I need to add up all of the side lengths. So I know that a rectangle has 4 side lengths, and I know that the actual length and the actual width are 56 feet and 24 feet. That means that to find the perimeter, I'm going to add 56 plus 24 plus 56 plus 24, since I know that the corresponding lengths across from them are the same. When I add 56 plus 24 plus 56 plus 24, I get a perimeter of 160 feet. That means that the distance around the swimming pool is 160 feet. Now let's find the area. Since this is a rectangle, I know that to find area, all I need to do is multiply length times width, or base times height. In this case, I'm multiplying 56 times 24. When I multiply 56 times 24, I get an area of 1,344. And because it's area, I need to show it in units squared. So the actual area of my swimming pool is 1,344 square feet. This problem says that we have a blueprint for a house. That blueprint uses a scale factor of 1 inch to 5 feet. This means that every inch on my blueprint represents 5 feet in real life. On my blueprint, the living room has a length of 2.5 inches and a width of 3 inches. We want to find the actual area of the living room. To be able to find the area of the living room, we need to find the actual length and the actual width of the living room. So we're going to use our scale factor, which says 1 inch to 5 feet. Let's start by finding our length. We're going to use the scale factor of 1 inch to 5 feet to make a ratio. And then we know that the length in our blueprint is 2.5 inches. So since inches are in my numerator here, I'm going to put inches in my numerator here. What I don't know is how many feet that is in real life. Now I'm going to take this and I'm going to cross multiply. 1 times x is 1x, which just gives me x. Then I'm going to multiply 2.5 times 5. When I multiply, I get 12.5. This means that the actual length for the living room is 12.5 feet. Now let's find the width of the living room. I again know that I'm using a scale factor of 1 inch to 5 feet. This time I know that the width of the blueprint is 3 inches. So since inches are in my numerator, inches will go in my numerator again. What I don't know is how many feet wide my living room is. Now I can cross multiply, and 1 times x will give me 1x, which is just x. 3 times 5 will give me 15. This means that the width of the living room is 15 feet. Now that I know the length of the living room and the width of the living room, I can use those to find the area. To find area, I'm going to use my formula area equals length times width, or base times height. And I'm just going to plug in what I know. My length is 12.5 and my width is 15. So I'm going to multiply 12.5 times 15, and now I'm going to get an area of 187.5. And because my living room is measured in feet, I'm going to say feet squared.